So LMs are great at a lot of things like reasoning. They're not great at forecasting. They're not great at different types of math. So we use the right tool for the right problem. And so if you already have tools across your business that are doing different optimizations, forecasts, different types of math that are important to you, you can build these tools and integrate them to add the power of reasoning from LM and AIP logic with these more deterministic tools or less stochastic tools, we can say, across your enterprise. So you can integrate things you already have across your AI journey here and have that complete visibility of when are you using them. So from an analyst, I can really start to trust what's going on here. I have this complete visibility into the chain of thought reasoning, what tools, what data I use to do it. All right, this is our vehicle maintenance inbox. I'm an auto technician with Titan Industries. My job is to keep our equipment on the road and operating. So you can see I have different claims here of issues that our drivers are having, and I can use this manual search to actually search across the PDF manuals, the unstructured data that comes with our equipment to maybe find a resolution for our drivers quicker. So if I come in here now, this is an actual claim from a user. During my routes, the seats in the cab of my 2023 Hallmaster get so hot that I have to take breaks more often than usual to avoid getting burned. That doesn't sound good. Let's see if we can help them out. All right. So if I hit semantic search here, this is actually going to create an embedding of this and then take that vector and look across the ontology and find the most similar embedding from those PDFs that we just processed through that pipeline. The one that was most semantically similar was actually this one, a Cargo Swift 2023 model for heated seat overheating issue. So actually, let's go generate a response here. So you can see the LLM that is backing this is actually able to understand that, well, these are actually a little bit different. So I'm not really sure if this is going to work. So it's saying, well, you asked about a Hallmaster, but I have found a PDF for Cargo Swift. Two different things, but maybe these could work, right? So this isn't super useful. Now, it's a cool demo if you're not paying attention to the details, but like this is the experience that we run into a lot of times. If you're just doing semantic search, it's going to find issues like this that if an unexperienced technician is looking at this, they might take that as the truth and go start to work on it. And actually, it's a negative value for them. So again, this is where these RAG workflows start to break down if you're just using semantic search. Okay, semantic plus keyword. How is this different? So just like in the simple semantic search, we're going to take the incoming claim or problem that our driver's having. We're going to create an embedding, a vector off of that, and we compare that vector against the ones in the ontology using a cosine similarity function, and it gives me back the most similar like PDFs. But before we do that, we're going to put in a keyword that actually filters down the corpus of potential things to go look at. So here, I'm going to make sure that Hallmaster is going to be in somewhere in the PDF to make sure that now it's only looking at Hallmaster PDFs as a knowledge base. Find the most semantically similar to this incoming text just with Hallmaster ones. All right, pretty cool. Let's see how that works. So great, I got a Hallmaster PDF, climate control related. So it's somewhat semantically similar, knows something about the temperature in the cab is not working great. So let's go generate a result like this. So I'm an experienced technician. I don't know that this really makes sense to me. I'm looking at this, it's about cabin air filters. This has nothing to do with the seat. This doesn't relate back to it. So really, this doesn't seem to be right for me. And if I was an inexperienced technician, I might be going out and trying to solve with this issue. So again, probably a net negative value here by giving the wrong answer that looks like it's right if you don't know what you're looking at.
In this application here, we're looking at a process model of an order-to-cash process that represents the business reality of our notional company, Titan Industries. And the process that is illustrated here basically covers all the steps from a sales order item being created, to goods being delivered, to invoices eventually being paid. Probably every single business on the planet operates this process in some form. In the context of this process flow, we've been alerted by a senior finance manager that there seems to be a problem with the resolution of credit blocks in this process, that we should investigate it and come up with resolution proposals. So if you're not an order-to-cash expert, you might now ask yourself, what is actually a credit block? A credit block is basically a risk management mechanism in most ERP systems used for customer order management. The idea here is to block orders from being fulfilled when there's a high risk of the order not being paid for by the customer. Using this process flow graph, we can actually see how this occurs in the process. When we pull over the slider here to unveil more variants of this process, you can actually see that in 2% of cases, sales orders are directly blocked after they're created. And this is, of course, a big problem, especially when orders are blocked, even though they will most likely be paid, right? If a customer has always paid on time historically, now gets a delayed fulfillment of her order, she will definitely not be happy, as it of course takes time to remove such blocks. In many companies, some person has to manually go into the system to remove such blocks. And this is exactly what is the case here. We know that because we have mined the process data from the source system in which these credit blocks are activated and removed. So we can quantify how long it takes to resolve these blocks. And with 9 days, which we can see on the top right here, the situation is really, really bad, at least on average. We want to be able to act more quickly than those 9 days. And we can use AI to do that. In the Take Action tab of this application, we can see in detail how this works. In this tab, we see all currently credit blocked sales orders. When we click on Show AI-generated resolution proposal, we move into an operational view for making a decision on whether to unblock this given order or whether to keep this credit block active. At the top of this view, we can see all relevant information for making the decision on what to do here. And at the bottom, we can see an AIP Copilot view. So here we basically have an AI reason to us on how this decision should be made. Right? We see a proposal on what to do here. We see the reasoning behind it, and we also see an animation of how taking the proposed next step would affect the ongoing process flow for this given sales order item. The underlying idea here is, of course, that by having access to such a copilot, or by even going beyond it with full AI-driven automation, we can significantly decrease the time needed to deal with these credit blocks. Because by this, we don't need full 9 days to make this decision. Either a human can directly accept what the AI comes up with, or the AI automatically executes what is proposed here, and this can be done obviously within seconds.
Titan Control Tower. This Titan is our notional data company that we use. We manufacture surgical equipment, masks, respirators, syringes, that kind of stuff. We've got customers, distribution centers. I just got worried that we had a fire at our Haynes Medical Distribution Center that we have a lot of our surgical masks at. So let's go take a look at that. Haynes, zoom in here. Let's see what the impact of how many customers and like kind of what type of customers we service out of this distribution center, so I can quickly see. I have different hospitals and medical centers. That's not gonna be great if they don't have surgical masks. So what are we gonna do about it? If we dive back into Haynes here, we're gonna pop out the copilot that we're gonna build today. So we have a copilot here, and this is our chain of thought reasoning. We're gonna put in our prompt of, hey, we had a fire. The facility that we think we're gonna cause shortages of surgical masks, like what should I do? So if we click this here, this is part of what we're gonna build. So this is gonna pass this prompt over to our LM function that we'll build. And you can see here, it's now going to start to go do something. So you see the supply chain tool. It's doing entity extraction, finding out which DC is the Haynes facility. So it's a Haynes Medical Supplies is the actual name. So you can see it did that entity extraction, went and searched the ontology using a data tool. Then the second thing is, okay, now I need to find what's the finished good. And it's able to figure out the surgical mask, go find the right surgical mask in the ontology of my business. So that different product definition. And you can see here, this is actually pretty cool. This is why I love the chain of thought. It's actually, hey, I made a mistake. I wasn't sure exactly the right thing. And it's able to course correct, but I can see that as a user to start to build trust about what is it doing? How is it finding this different things? Awesome. Now it's going and finding all the different customer orders that I'm going to need to update. So I know I'm going to have to ship these customer orders so I don't short them from somewhere else, but where do I have inventory? Right. So it's going to go find, other warehouses that have the same inventory, that finished good, and it's going to tell me what the orders are that I need to go update, how much, and to what new distribution center. So you can see DC11 had enough inventory, and it's writing out all the different customer orders that I need to go update and by which quantity. So if I'm an analyst and I had this fire, this is pretty awesome. Within just a few minutes here, I'm able to actually go figure out what I should go do about this fire so that I don't short customers. Augmented generation, so it's retrieving data from my ontology, the knowledge of my business. But when we talk about OEG, that's really the ontology augmented generation, and that's where we start to dive into now, how do I use functions, right, the other pieces of the ontology, to maybe have an optimizer that's going to help me pick the right DCs that are at the lowest cost, shortest route, best thing for the customer, and then also back to like action, right? So if we think about the action component of the ontology. Don't just tell me what the orders are or tell me what the optimized orders are. Tell me, like, here's the approval. Should I go do this? Yes, right? And that's how we start to actually then take actions right back to the SAP system. Update the orders for me. You start to see how now AI plus humans, and this is how we're empowering humans through AI. Pretty cool. So now it's telling me exactly what I need to go do. In this case, I'm a supply chain analyst. This is the Titan control tower. This is what I use to navigate and look at my supply chain. We heard there was a fire in the Haynes Medical Supplies distribution center that we distribute face masks to a hospital from. Not great if we had a fire in a face mask distribution center. So we're going to start shorting customers at hospitals. They need face masks to operate. So how do we navigate this? Last time we built this copilot that would navigate the ontology and find where the customers that would be impacted, where might have enough inventory to supply out of, and go change those orders. So it gave us the list of orders. Great. But it's going to take a while to recover from a fire. So how are we going to manage this in our supply chain? We probably want to forecast out a longer period of time of customer orders so that we make sure we have inventory in the right place at the right time so we don't short these hospitals the masks they need. So that's what we solved last time. So we're going to add in this logic function for forecasting. If we click this, we're going to go. And so now this is going to take this intent, figure out which tools I should go use. In this case, we've given access to the supply chain tool that we just updated to the new version, right? That has access to the forecasting tool. So you can see it's already going to use that tool. It's showing the chain of thought reasoning. And now this is similar to what we saw in our AIP logic debugger. It's going to do the entity extraction for surgical masks. It's going to do the same thing for distribution centers. So think about me as an analyst. I see what's going on. I have this complete visibility. This isn't cutting me out of the loop. This is really human in the loop AI, us working together to get things done more efficiently. I can even go navigate, I want to go look at this order or that order. It gives me that visibility in the chain of thought to actually go look at what it grounded the truth in the ontology. What objects was it looking at? Let me go investigate. You have that complete visibility here. Also to what tools. This is very, very cool. I actually used an LM to call and create a forecast and use that forecast output to do something more intelligent in my business. And I have that visibility as a user. But now I need to assess the damage at the Haynes facility. So I'm going to extend the ontology we built already as part of Titan to include tasking different public satellites. We're going to use LLMs to help me find the right satellite with the right imagery that I need. So you can see in the React app running on the iPad above me here, we built this on top of the OSDK, leveraging the same ontology I used for my Titan control tower. It's giving me this list of distribution centers to be represented. Now I've got satellites moving and I want to go zoom in and look here. So my Haynes facility, I'm going to get on a plane later and go take a look at Haynes, but I want to have some satellite imagery to see what's going on. So here's my Haynes medical supplies. I want to create a task for that. I'm going to use this, and this is actually going to call the LLM function. So now this is navigating the ontology on my behalf, looking at the planned events, what's going on. So it knows that it has a fire. Okay, I've got to go find a satellite that's going to go over that path in Mountain View that has the sensors that I need to assess the damage from a fire. Very cool. All right, awesome. Got me a satellite, satellite 52174, and I can hit save here. So when I do this, it's actually going to write back to the ontology, create this sensor tasking object. Now that could have a webhook to an API to a satellite provider. It could go back to SAP, wherever that needs to go. So I've created that, and again, it wrote back to the ontology and immediately populated the application because the taskings are part of the OSDK. We're in the world of procurement, from RFPs to evaluating vendors to managing contracts, all the way to ensuring vendors are following our agreement. We do this with a multimodal LM, powering a seamless workflow, ensuring we get the best deals, hold our vendors accountable to the terms we agreed upon, ultimately saving us time and money. Let's dive right in. All right, if I'm in the procurement department, part of my job is helping select new vendors based on a certain set of requirements for my organization. So normally I help put together an RFP or a request for proposal. This is great, but it's all very unstructured, right? It's stuck in PDFs and Word docs, but it doesn't have to be that way. This is our RFP parsing review app. So you can see here, I've actually got the RFP, the PDF here version, and we've used AIP to actually extract and manipulate and understand what's going on in the document. So we've created a summary, an objective. It's also extracted the entities around timeline and milestones, requirements,
even put categories and requirement types in here and what page on the PDF it's referencing. So ultimately, I'm taking unstructured and I'm creating the structure. But you can see I also have the ability to edit. I can add a new milestone in for when the contract decision is going to be made, or I can edit the summary to add a couple extra notes of clarity. This is how we have human in the loop AI. So I can click through and you can see how we can analyze each one of these. But how does that actually work? So we've got another tool called Automate. So Automate is an event-driven engine that allows us, when things happen in the ontology that happen in your business, they trigger events and processing other things. So in this case, when a purchase order comes in, we want it to automatically then trigger an AIP workflow to do the matching and violation detection. So that looks like in this use case here, I've got a purchase order coming in, and now I want to run this AIP logic function to detect and create those alerts. So pretty cool in here. It's really easy to configure. You can actually just hit edit here and we'll take a look. So you can see the object set that's coming in. We're going to say for each purchase order that comes in, I want you to actually process this. And it's going to call an AIP logic function to go do that. So now that AIP Automate is running for every purchase order coming in, looking for these violations across my contracts, that's great. Now the scale of these might be hundreds of thousands of contracts and even more purchase orders. So it's massive. So with AIP Automate, AIP Logic here, I can decode these things, alerting me to the most important things I should be working on in my business. This is awesome. This is how AIP turns you from a problem observer to a problem solver. All right, so this is a workshop app. That's our low code, no code offering for building applications, interactive applications, as you can see here. This is a chat experience, and we'll put a prompt in here. This is using some notional data we'll look at in a second, but it's a manufacturing company called Titan. That's our notional data company. And we have data on trouble tickets from the manufacturing floor about the problem and the resolution from engineers. How do we leverage that so we can help reduce downtime by resolving issues quicker using past knowledge? So all that's sitting in free-form text fields today. How do we take that embedded knowledge in your business and leverage it like this? So you can see I asked a question about the ear loops on my master coming off. What should I do? I'm using LLM functions that we're going to go build to navigate the ontology that is based on data sitting in BigQuery. So lots of really cool stuff going on here. And it summarized those past resolutions into things I should go look at to resolve my issue quicker. When I click this is now, I'll just walk you through this. When I click this button, it's going to take this text. It's going to send it to my AIP logic function that we just created, right? And so now it's doing that. And you'll see here, so I can see Frank's using the user function tool, so the resolve me AIP logic function, the LLM back function, and you can see the chain of thought reasoning here on the right is it's actually showing all the steps, the objects. I can go click on these objects, investigate them, and it gave me a resolution, and boom, I got this nice text here. You can also dig in here and look at the different tools and pieces. Lots of neat stuff you can do here, but think about that. Now, all this stuff that's buried in your unstructured data that's really hard to unwind or use in traditional like BI tools or things, I create these interactive experiences.